All right, today we're going to go over classification of matter. After today, you should be able to differentiate between mass and weight, compare and contrast the properties of the states of matter, classify matter into categories including pure substances and mixtures, and explain the difference between homogeneous and heterogeneous mixtures. Some people also say homogeneous and heterogeneous. I'm from Dayton, so I just say homogeneous and heterogeneous. So what is chemistry? It is the study of matter and the changes it undergoes. So some terms you've seen before. Matter, anything that has mass and volume, so everything. Mass, the amount of matter in an object, how much stuff it is. Energy, anything that can do work or produce heat. And weight, the force of gravity acting on an object's mass. You should have seen these before in, I believe, 8th grade. Now, review of solids. Solids are barely moving. They're tightly packed together. They're vibrating in place. Liquids, they have more energy, so they're moving around, flowing past one another. And gases have a lot of energy, so they're bouncing off the walls, going crazy. No definite shape, no definite volume. And don't forget, there is a fourth state, plasma. And it is so high in energy that it actually loses electrons. Now, the newest thing on here is going to be the density. So if you look at this, solid is high density. That means how tightly packed it is together. This is less dense, and this is even less dense. There are two major areas that matter are classified into: pure substances and mixtures. Pure substances have uniform and definite composition. The first thing that you can classify pure substances as is elements. So elements are going to be anything that you can find on the periodic table, and it's by itself. So it's described by symbols: H for hydrogen, He for helium, Li for lithium. Then you have compounds. These are formed when elements chemically combine. So this is when two or more of those elements on the periodic table get together. It doesn't matter what the numbers are, if they're in the front and the back, but anything like this, we have H2O, which is water, CO2, which is carbon dioxide, and then you have NO2. It could be something as big as C6H12O6. That's all C, H, and O are on the periodic table, so they're compounds. So mixtures are two or more pure substances physically mixed together. In compounds, these elements are bonded to each other. In mixtures, the substances are blended. So mixtures are blended. There's no definite composition. We don't assign a fixed ratio. Now, there are two types of mixtures. We have heterogeneous mixture, does not have a uniform composition. You can actually physically see the differences and things can be picked out. So this is going to be a fruit salad, cereal and milk, vegetable soup. You can see the soupy part, and then you can see the actual vegetables floating in it. You can pick them out. Homogeneous mixture has a uniform composition. Things cannot be picked out. So like sugar water and milk. Then you have a colloid. These are where particles of one substance are dispersed through a second substance. So you have one thing packed in another thing. And examples are whipped cream, mayonnaise, milk, butter, gelatin, jelly, muddy water, plaster, colored glass, and paper. Then you have a suspension. This is a heterogeneous mixture, which means we can see the different little pieces of it, in which some of the particles settle out the mixture upon standing. So it separates. An example of this is lemonade. If you leave lemonade sitting there for a long period of time, you will get the sugar settling to the water. You will see the actual, if you use real lemonade, like real lemons to make it, you would see pulp settle at the bottom and things like that. So, for example, you have a mixture of chalk and water. You have muddy water, mixture of flour and water, dust particles in air, those little bitty things that swirl around, fog, and milk of magnesia. And lastly, we have something called the Tyndall effect. This is going to be the scattering of visible light by colloidal particles. So the Tyndall effect is basically the scattering of light. So with the solution, there is no scattering of light. It goes just, there's no issue. With the colloid, you've got slight scattering of light. And then with the suspension, you have more. So here's an example. A solution, the light beam is not visible. With the colloid, the light beam is visible, and the suspension is visible as well. With the suspension, it is way more visible. So that's it. That is the PowerPoint for classifying matter.